demonstrating my project 2 for visualization course here at Stony Brook University. So this project required us to do random sampling, stratified sampling, PCA and MDS on our selected database to help visualize it. So I'll just first describe how the dataset looks like. It is a Pokemon dataset which has 800 data points and 20 feature values. So the 20 feature values contain name of a Pokemon, classification, into which type of a Pokemon it is, weight of a Pokemon, etc. So the first task was to do random sampling, and as you can see I have selected 25% of my whole data randomly. The second task was to do stratified sampling. Now stratified sampling requires us to do k-means clustering first. Now to do k-means clustering we need the optimal number of clusters that we can divide our dataset into. So as you can see the first graph here, so we use an elbow method for finding out the optimal number of clusters. As you can see here at 0.7 number of clusters, the tangent to this graph here is equal to the tangent, is parallel to the tangent here, and hence we can divide our dataset into 7 number of clusters using the elbow method. After doing this, I did PCA on my dataset, and this is for the whole dataset. So here x-axis shows the component number and y-axis shows the explained variance ratio. Now as you can see at 0.10 as a number of component, 10 number of components, the explained variance crosses 75%. Hence that is our intrinsic dimension for this dataset. Now this PCA was for the whole dataset. If we do it for randomly sampled data, we have a slight change in the values but not huge, and our intrinsic dimension stays the same. And for stratified sample data, intrinsic dimension stays the same, but the value for the first component increases slightly. After doing PCA, we were required to find out the top 3 original features in the dataset that can define the dataset properly. So for that we found out the loading scores using the PCA algorithm, and as you can see the top 3 features here are name, classification and type 2 of a Pokemon, and their SSL scores are shown on the y-axis for the whole dataset. For randomly sampled dataset, these top 3 features change to classification, type 2 and name, and their SSL scores also change, and these SSL scores are found out using the intrinsic dimension using the PCA. And for stratified sample dataset, you can see the feature values have again changed, the top 3 original feature values, and they have some SSL scores here. After doing this, our third task was to make a scatter plot, 2D scatter plot using the first 2 component values using the PCA. So here is the 2D scatter plot using the first 2 components value, as you can see PC1 and PC2, and as you can see the dataset has been divided into 7 clusters that we found out using the k-means method. They are clearly divided into clusters. Now this is the same thing for randomly sampled data. As you can see the number of points have decreased as we took only 25% of the dataset, and this is for stratified sampling, the same thing, PC1 versus PC2. Now we were supposed to do MDS using the Euclidean dissimilarity function on the whole dataset, and as you can see the 2D scatter plot is similar to this plot, but the orientation has changed, but it is preserving the Euclidean distance between the points between the PC1 and PC2 values. This for the whole dataset. This is for randomly sampled dataset, MDS using the Euclidean dissimilarity, and this is kind of similar to the PCA we did on the randomly sampled data, only the orientation has changed. This is Euclidean on stratified dataset. This is again similar to PCA on stratified dataset, and yes, now we did MDS using the correlation dissimilarity on the whole dataset, and the plot is an ellipse. As you can see the clusters have been divided perfectly into their own regions. This is MDS with correlation dissimilarity on randomly sampled data, and this is correlation dissimilarity MDS on stratified sample dataset, and the clusters are pretty clear here than the randomly sampled one. The last task was to plot a scatter matrix of the top 3 original features using PCA, and for the whole dataset the top 3 features were name, classification and type 2 of a Pokemon. That we can confirm from here, name, classification and type 2, and we plot a scatter plot matrix for that, and the different points are being shown here. And the scatter plot matrix for randomly sampled data looks like this, and scatter plot for stratified sample data looks like this with their top 3 feature values. And this is it for this project.